Good morning, students. In the last class, we discussed about when a resistor is connected to an AC source, right? So today class we are going to discuss about when an AC source is connected to a capacitor. So here we are going to discuss about what happens when an AC source is connected to a capacitor, right? So parallel plate capacitor having capacitance C is connected to an AC source having the voltage V is equals to Vm sin omega t. So AC source which we are applying to the capacitor, so that voltage we taken V is equals to Vm sin omega t, right? So before going to discuss what happened when the capacitor is connected to the AC source, so before going to discuss AC source, so first we are going to discuss about the DC source, right? So what happens when a capacitor is connected to the DC source? So having applying the voltage V, right? So the capacitor having the capacitance C. So when we apply the potential which is across the capacitor, the current starts to flow across the capacitor, right? So when DC source is connected having some potential which is applied across the capacitor, the current starts to flow. So as the current is flowing, that means the charges are flowing in the circuit, right? So we know the relation I is equals to Q divided by T. So we define the current charges flowing per unit time, so that one is the current, right? So here the current is flowing means the charges are flowing. So what is capacitor? So capacitor stores the charges, right? So as the current is flowing across the capacitor, so capacitors gets charged, right? So in a parallel plate capacitor, the charges are stored in the capacitor, right? So charges is Q. As the capacitor is fully charged, then the potential is increases across this capacitor, right? So that is C is equals to Q divided by V, right? So Q is equals to CV. So as the number of charges which are accumulated on this capacitor, the number of charges increases where C is a constant, then the potential across the capacitor is also increases. As the potential increases, it restricts the flow of the current across this circuit, right? So voltage just the current which is flowing in the circuit. So as the voltage increases, it restricts. That means it stops to flow of current in the circuit when the capacitor is fully charged. So when capacitor is fully charged, it restricts the flow of current in the circuit. As it restricts the flow of current, so hence the current flowing in the circuit is zero, right? So that means the capacitor blocks the current which is flowing in the circuit, right? So current flow is only for a short interval of time. That is only for a small interval of time. dt delta t. So small interval of time only capacitor ಏನಾಗುತ್ತೆ completely charge ಆಗುತ್ತೆ. That means completely store ಆಗುತ್ತೆ charges. As the capacitors gets charged, the voltage across the capacitor increases, right? So as the voltage increases, it blocks the flow of current in the circuit. That means it blocks the current in the circuit. So last current electricity problem ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ತಗೊಂಡಿದ್ವಿ. So when the capacitor is connected to the external circuit, so the current flowing across this circuit is zero. That is because the voltage across the charged capacitor increases, that blocks the current which is flowing across the circuit, right? So this is what happens in DC circuit. So DC circuit ಅಲ್ಲಿ ನಮಗೆ current in an external circuit ಏನಾಗಿರುತ್ತೆ zero ಆಗಿರುತ್ತೆ. That means capacitor blocks the DC current. So that means direct current. That means blocks the DC current means the current flowing in the circuit is zero. So this is what happens in the capacitor which is connected in DC source. That means DC voltage ಗೆ ನಾವು ಕೆಪಾಸಿಟರ್ ನ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ದಟ್ ಸರ್ಕ್ಯೂಟ್ ಏನಾಗಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ ರೈಟ್ ಸೊ ಇಲ್ಲಿಗೆ ನಮ್ದು can't study about the capacitor so ಏನಾಗುತ್ತೆ ಸ್ಮಾಲ್ ಟೈಮ್ ಗೆ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗುತ್ತೆ ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗ್ತಿದ್ದಂಗೆ ವೋಲ್ಟೇಜ್ ಏನಾಗುತ್ತೆ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ ವೋಲ್ಟೇಜ್ ಇನ್ಕ್ರೀಸ್ ಆದ್ರೆ ಕರೆಂಟ್ ನ ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡುತ್ತೆ ದಟ್ ಮೀನ್ಸ್ ಸ್ಟಾಪ್ ಮಾಡುತ್ತೆ so hence it restricts in the current means here the flow of current is 0 right so this is what happens when capacitor is connected to the DC source right so but here in AC source so AC source means alternating voltage so here we are applying only the direct voltage so direct voltage we are applying means direct current is flowing that means constant current is flowing but in alternating source the current is varying sinusoidally from positive value to negative value across the zeros so sometimes the value of current may be positive and sometimes the current may be negative right so here also the current which is flowing in the initial time right so as the current flows right here I will write so this is V omega so this is the voltage we are applied across this capacitor right so in the positive half cycle so this we call as the half cycle and this is the remaining half cycle so completing two half cycle become says that is the one cycle time period for one cycle right so during half cycle only the positive value of the voltage is flowing across this capacitor that means only the positive current is flowing across this capacitor and capacitor gets charged right so current flowing for a small interval of time during the first half cycle so from 0 to pi here it is 2 pi right so ilinda ilige yavudu either it may be small or that means lesser value or greater value so magnitude ಏನಾಗ್ತಿದೆ ನಮಗೆ ವೇರಿ ಆಗುತ್ತೆ increase ಆಗುತ್ತೆ ಮತ್ತೆ decrease ಆಗ್ತಿದೆ but the value is positive value so in this cycle we have only the positive voltage that means we are getting the positive current so positive current flow ಆಗ್ತಿದೆ ಅಂದ್ರೆ capacitor gets charged that is similar to that of the DC right so capacitor fully charge ಆಗ್ತಿದೆ next ಏನಾಗ್ತಿದೆ during the second half cycle so during second half cycle the voltage value is negative right so that means minus value that is current is flowing so that is the negative value so that time the capacitor gets discharged so capacitor ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ it loses its charges in the circuit right so here during the positive half cycle the capacitor is charging and during the negative half cycle the capacitor is discharging that means ಏನು ಚಾರ್ಜಸ್ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೋ ಆ ಸ್ಟೋರ್ ಆಗಿರೋ ಚಾರ್ಜಸ್ ಏನಾಗುತ್ತೆ ಫ್ಲೋ ಆಗೋಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ during the negative half cycle right so that means there is a flow of current in the external circuit right so initially ಎಷ್ಟು current flow ಆಗ್ತಿದೆ ಅಷ್ಟು flow ಆಗದಲ್ಲ ಇದ್ರು but somehow it is flowing that means the current which is flowing across the capacitor but when in DC voltage the current across the capacitor is completely zero but here we are getting some current that means it restricts some value of the current and it allows some value of the current right so here we are going to find the how much current which is flowing across this capacitor right so this is the applied voltage so this is sinusoidal wave that is we are applied the voltage is in the sine wave that is V is equals to Vm sin omega t right so ಇಲ್ಲಿ ನಮಗೆ we are going to discuss about the current right so as we know C is equals to Q divided by V that is voltage across the capacitor is V is equals to Q divided by C right so from Kirchhoff's law so this is the applied voltage V is equals to Vm sin omega t is the applied voltage from the AC source and here the voltage which is across the capacitor C we getting V is equals to Q divided by C that is from the formula of the capacitance C is equals to Q by V right so from this the voltage that is from the Kirchhoff law the voltage which we are applied that is equals to the voltage that is across the capacitor, right? So from these two equations, from equation 1 and equation 2, the LHS remains same, hence we can equate the RHS, right? So that we can write Vm sine omega t, that is equals to Q divided by C, right? So now from this we can write Q is equals to C Vm sine omega t, right? Calling this one as equation 3. So here we are going to find the current which is flowing in the circuit, right? So again from the definition of the current, I is equals to dq divided by dt. That is because only small amount of the charges which are flowing during the positive off cycle and also during the negative off cycle. So hence we taken I is equals to small change in charges with respect to small time, right? So from equation 3 we have the value of Q, right? That is C Vm sine omega t. So here capacitance of a capacitor is constant and the applied voltage which we are applied in the AC source, so that is also the constant. So we can take these two as common, CVm. Now we differentiate d by dt of sine omega t, right? So if we differentiate this one, we get CVm cos omega t. Again, if we differentiate omega t, we get omega, right? So that we can write I. So I is equals to C omega Vm cos omega t, right? Now we can rearrange this in the form I is equals to, we can take this whole as constant, right? Omega is constant, C is constant and Vm. So this constant will be replaced by the another constant. So that is Im cos omega t, right? So this cos omega t can also, we can write this as I is equals to Im sine of omega t plus pi by 2. So this is from the trigonometric function, right? So the current which is flowing in the circuit, so that we get I is equals to Im sine omega t plus pi by 2. So sine of 90 plus theta, again we getting the cos theta, right? So this will comes under the second quadrant. So second quadrant cos is positive, right? So where Im, we replace the value of Im, that is equals to C omega Vm, right? So now compare this, or we can rewrite this one as Im is equals to Vm divided by 1 by omega C, right? So we can rewrite this C omega Vm as Vm divided by 1 by omega C. So if it goes to the numerator, again we get C omega Vm, right? So compare this with the Ohm's law or from the previous session, that is resistor is connected to the AC source, right? So compare this with the equation Im, that is equals to Vm divided by R, right? So comparing these two equations, so here in place of Im we having the Im, that means the peak current or peak Vm is the peak voltage, and in place of R we written 1 by omega C, that means 1 by omega C acts as a resistance in the capacitor, right? So this we taken 1 by omega C is called the capacitive reactance. Capacitive reactance, that means it is nothing but the resistance. So if we compare these two equations, in place of Im we having Im, in place of Vm we having the Vm. So in place of R we get the value of 1 by omega C, where R is the resistance. That means 1 by omega C is the resistance which is acting in this capacitor when the AC source is applied, right? So this 1 by omega C we call that one as the capacitive reactance, and it is denoted by Xc, that is equals to 1 by omega C. So capacitive reactance is denoted by Xc, and its unit is same as the resistance unit, so that unit is ohm. where X is the capacitive reactance, that is nothing but the resistance in the capacitor. That means it opposes the flow of current, that means there is a resistance. So the nature of the resistance or the property of the resistance is it opposes the flow of current in the circuit. So here also it opposes the flow of current, so that we getting Xc, calling that one as the capacitive reactance. Xc is equals to 1 by omega c, where omega is the angular frequency and c is the capacitance of the capacitor, right? So this Xc, we can write Xc is equals to 1 divided by omega is 2 pi f into c. So Xc is inversely proportional to the frequency of the voltage or frequency of the current, right? So here we are taken current because here we are defining the current. So hence the capacitive reactance is inversely proportional to the frequency of the current, right? So this is about the AC source when we connected to the capacitor. So here we applied voltage is V is equals to Vm sin omega t, and the current which is flowing in the circuit is I is equals to Im sin omega t plus pi by 2, right? So here Im is a constant and that value is C omega Vm. So we can rewrite this as Vm by 1 by omega C. This we call as capacitive reactance. So very important while solving the problem, this should be, you have to remember, right? So capacitive reactance is 1 by 2 Fc or omega C, right? So now we will discuss the variation of voltage and current, right? So the applied voltage is V, that is Vm sin omega t, and current we get is I is equals to Im sin of omega t plus pi by 2, that is pi by 2 plus omega t or omega t plus pi by 2. So you know same. So how we get this waveform in graphical representation, right? Omega t and I is the current which is flowing in the circuit, right? So here is the maximum Pm value, 0 value, again minimum value, right? So here it starts from 0, here it is pi by 2, 3 pi by 2, right? Now comparing with this waveform, so initially when voltage is 0, right? So initially when voltage is 0, that means omega t is 0. So this omega t is 0 means sin 0 is 0. So 0 into Vm is 0. So we get V is equals to 0, right? So next when this omega t is pi by 2, right? Substituting the values of omega t is pi by 2. So we get the value of sin 90. Sin 90 is 1. So we getting 1 into Vm is Vm. That means we are getting the peak voltage, right? So this we call as the peak voltage Vm, right? So now in the same way here we substituted in this case pi by 2. So initially we have substituted omega t as 0 in the voltage. So same wise for the same value when omega t is equals to 0 here, right? So in the first case omega t is equals to 0. So sin of 0 plus pi by 2 we getting pi by 2, right? So sin 90 is 1 into Im is Im. So when omega t is equals to 0, so we getting I is equals to Im, right? So omega t is 0 idaga voltage ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ, but current ಏನಿರುತ್ತೆ ನಮಗೆ peak current ಇದೆ. Substitution is omega t is equals to pi, right? Here, so when omega t is equals to pi, that is equals to 0, sin 180 is 0, 0 into Vm is 0, and V is we getting 0 here, right? So same as here omega t is equals to pi plus pi by 2, taking LCM we get 3 pi by 2, right? So 3 pi by 2 is what? That is 270. So sin 270 is minus 1. So minus 1 into Im, so minus Im, right? So when pi we getting value somewhere here negative value, right? So next case, I is equals to minus Im, right? So next, omega t is equals to 3 pi by 2, that is 270. After 180, we are substituting the value 3 pi by 2. So here 3 pi by 2, that is 270. So sin 270 is minus 1, minus 1 into Vm, we get it minus Vm. So here we are getting the minus Vm, right? So this is minus Vm. So same if we substitute here 3 pi by 2 plus pi by 2. So 2 pi by 3 pi by 2 plus pi by 2 is 4 pi by 2, that is 2 pi. 2 pi is equals to 0, so sin 0 is 0, so 0 into Im is 0, so we get I value that is equals to 0, right? So somewhere here we getting the 0. So next and the last one is 2 pi. When omega t tends to 2 pi, so sin 2 pi is 0, so 0 into Vm is 0, so here the voltage is 0. When voltage is 0, so 2 pi plus 5 by 2, right? So that is 5 pi by 5 pi by 2, so 5 pi by 2 is 1, so 1 into Im is Im, so we getting I is equals to Im, right? So somewhere here we get it. So if we complete this curve, we get again the sinusoidal curve like this, right? So from this we can observe when voltage is 0, we are getting the maximum current, that is the peak current. When voltage is 0, we are getting the peak current. When voltage is maximum, we are getting current is equals to 0. So the value of difference, that is the value of the values from maxima to 0 and 0 to minimum, that is range in between from 0 to pi by 2, right? So there is a change of voltage, maximum voltage to the maximum current by an angle is pi by 2. So here the difference angle is how much? That is pi by 2, right? So voltage ನಮಗೆ 0 ಇದ್ದಾಗ ಆಲ್ರೆಡಿ ನಮಗೆ ಕರೆಂಟ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರುತ್ತೆ, ರೈಟ್? ಸೊ ಇಲ್ಲಿ ವೋಲ್ಟೇಜ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರ್ತಿದೆ ಅಂದ್ರೆ ಕರೆಂಟ್ ನಮಗೆ ಏನಿದೆ 0 ಇದೆ. ಸೊ ದಟ್ ಇಸ್ ದ ಡಿಫರೆನ್ಸ್ ಆಂಗಲ್ ಇಸ್ ಹೌ ಮಚ್? ದಟ್ ಇಸ್ pi by 2. ದಟ್ ಮೀನ್ಸ್ ಕರೆಂಟ್ ಗಿನ್ನು ಮುಂಚೆ ವೋಲ್ಟೇಜ್ ಗಿನ್ನು ಮುಂಚೆನೆ ಕರೆಂಟ್ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲಿ ಬರ್ತಾ ಇದೆ. ದಟ್ ಮೀನ್ಸ್ ಕರೆಂಟ್ ಲೀಡ್ಸ್ ದ ವೋಲ್ಟೇಜ್ ಬೈ an angle pi by 2. So from this graph we can state that current leads or ahead. So current voltage ಗಿನ್ನು ಮುಂಚೆನೆ ಕರೆಂಟ್ ಏನಿದೆ ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ರೀಚ್ ಆಗ್ತಿದೆ, ರೈಟ್? ಸೊ ಕರೆಂಟ್ ಲೀಡ್ಸ್ ದ ವೋಲ್ಟೇಜ್ by 90 degree, or that is pi by 2, or in terms of time period is 1 by t, right? So 1 by t. So 1 by t time ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗ್ತಾ ಇದೆ, ಕರೆಂಟ್ ವೋಲ್ಟೇಜ್ ಗಿನ್ನು ಮುಂಚೆನೆ ಇರುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ವೋಲ್ಟೇಜ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ರೀಚ್ ಆಗೋಕ್ಕಿಂತ ಮುಂಚೆನೆ ಕರೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಮ್ಯಾಕ್ಸಿಮಮ್ ರೀಚ್ ಆಗ್ತಿದೆ. ದಟ್ಸ್ ದ ಡಿಫರೆನ್ಸ್ ಇಸ್ that is pi by 2. So ನೀವು ಇಲ್ಲಿ succeeding cases ಅಲ್ಲಿ ಕೂಡ ನೀವು ಚೆಕ್ ಮಾಡೋದಾದ್ರೆ, so when current reaches the negative, that is minimum value, so before it going to voltage going to minimum value, the current will reaches the minimum value again by the difference is pi by 2, right? So ಇಲ್ಲಿ pi ಇದೆ, ಇಲ್ಲಿ 3 pi by 2 ಇದೆ. So the difference angle is pi by 2. So maximum ಮತ್ತೆ minimum vary ಆಗೋದಕ್ಕೆ the angle which needs the difference is pi by 2. So from this, comparing these two, we can say that current leads the voltage by pi by 2. That means current reaches maximum before the voltage it reaches, right? So that's the statement we need to remember is current leads the voltage by 90 degree or pi by 2 or 1 by t. That is the time period. So better you can only remember by 90 degree or pi by 2, right? So this is about the AC source when connected to the capacitor, right? So by using this we can write like this, right? So this is the voltage V, right? So current is ahead by 90 degree. So this is what that is the 90 degree. So graphical representation waveforms alidre. So symbolic representation ali bandu in terms of phasors. So voltage is in this direction, current is perpendicular to the voltage. That means it's always 90 degree. So if we represent this in case of phasor, phasor means rotating vector. As the voltage rotates about the axis, right? So this is voltage. So current value is always less than that of the voltage, right? So this is current. Again here it should be the pi by, right? So if it rotates with an angle omega t1, so in that case also the voltage is perpendicular to that of the current. That means current, this is we are rotating in the counterclockwise direction. So ಇದನ್ನ ಈ ತರ rotate ಮಾಡಿದ್ರೆ ನಮಗೆ ಏನು ಸಿಗುತ್ತೆ ಅಂದ್ರೆ voltage which is rotating in the counterclockwise direction for an angle omega t1. So omega t1 vary ಆದಂಗೆಲ್ಲ ನಮಗೆ value of the v and I ಕೂಡ vary ಆಗ್ತಾ ಹೋಗುತ್ತೆ. So as these two are the phasors and its amplitude is denoted by, if v is the phasor, so its amplitude is denoted by vm, right? So amplitude of the phasor vector v, that is denoted by vm, and also the amplitude of I phasor, that is denoted by Im, right? So this is again equals to Vm sin omega t1 Im sin omega t1 plus pi by 2, right? So that means if we resolve this component along vertical component, so we getting Vm sin omega t1 sin omega t1 plus pi by 2. So capacitor always current leads the voltage by an angle of pi by 2, right? So ಇದು ತುಂಬಾ important ನಮಗೆ ಇದು ನೆನಪಲ್ಲಿರಬೇಕು. That is the statement, current leads the voltage by an angle 90 degree and the phasor diagram is, so ನಾವು phasor diagram ಯೂಸ್ ಮಾಡ್ಕೊಂಡು next ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಈ ಡಯಾಗ್ರಾಮ್ಸ್ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗುತ್ತೆ, right? So if you take a voltage along x axis, then the current will be perpendicular to that of the voltage, right? So that is V and I are perpendicular to each other by an angle 90 degree. If we rotate the voltage by some angle, that is omega t1, then I is also rotate with same omega t1 along with the angle pi by 2, right? So V now omega t1 angle ಅಲ್ಲಿ rotate ಮಾಡಿದ್ರೆ I ಎಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ omega t1 plus pi by 2 ಅಷ್ಟು ಚೇಂಜ್ ಆಗುತ್ತೆ. That means the total angle between the axis of I is pi by 2 plus omega t1, right? So this is all about the AC source when it is connected to the capacitor, right? So ತುಂಬಾ important concept. So previous years ಅಲ್ಲೆಲ್ಲ ನಮಗೆ ಡಿರೈವೇಷನ್ ಕೇಳ್ತಾ ಇದ್ರು, ಬಟ್ ಈ ಸಲ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಡಿರೈವೇಷನ್ ಇಲ್ಲದೆ ಇರೋದಕ್ಕೆ ಸೊ ಈ ಎರಡು ಕೀ ಪಾಯಿಂಟ್ಸ್ ನ ನೆನಪಿಟ್ಕೋಬೇಕು. ಅಪ್ಲೈಡ್ ವೋಲ್ಟೇಜ್ ಇಸ್ Vm sin omega t1 and I is equals to Im sin of omega t plus pi by 2, right? So next we will discuss what happens when AC source is connected to an inductor. So this we will discuss in our next class. Inductor is nothing but a coil, right? So aduna ನಾವು previous chapter ಅಲ್ಲಿ study ಮಾಡಬೇಕಾಗಿತ್ತು only. So here small concept ಬರೋದ್ರಿಂದ so chapter skip ಮಾಡಿರೋದ್ರಿಂದ indicate inductor is nothing but a coil, right? So it stores the energy when the current is flowing into the inductor, right? So inductor is nothing but a coil, or it is a device which stores the energy, that is electromagnetic energy. That means it stores the EMF, right? So when the current is flowing in the coil or in the inductor, right? So So that EMF we can write E, that is equals to minus L into di by dt, right? So EMF we are getting, that is small change in current with respect to time, and L is the constant, that is the inductance of the coil. So L is a constant, or constant ನಾವೇನಂತ ಕರಿತೀವಿ inductance ಅಂತ ಕರಿತೀವಿ, right? So what happens when AC source is connected to the inductor? So as now capacitor ಯಾವ ತರ study ಮಾಡೋದು, in the same wise here also the voltage we are applying is Vm sin omega t, right? So here the current is flowing in the circuit, that is current is flowing in the coil. So here this we call that one as a pure inductor. So pure inductor nothing but there is no resistance across the inductor, so that we call as the inductor, right? So it does not opposes any flow of current, antaduna navenanta karithivi pure inductor, right? So what happens when the AC current is flowing across this inductor, right? So that we will discuss in our next class, right? Thank you.